We ended the last video with an example where we wrote things in expanded form. That's going to be when we use our rules of logs to take one log and break it apart into smaller pieces, trying to make the argument of each piece as simple as possible. The other type of problem is when we go the other way, when we start with multiple logs and we try to combine them into just one. Those directions will generally say write as a single log with coefficient 1. Okay. Right now, that part of the definition isn't particularly necessary. That's going to become more relevant once we learn the next rule of logs. But I just want to get you used to those directions. So this part is going to sort of take care of itself for this particular problem. So I want to look and see, oh, I'm subtracting. So which subtraction can I simplify? I know that when I'm dividing, I subtract exponents. So I can simplify the subtraction if what I'm subtracting is exponents or logs. So I can simplify this subtraction problem. So this is going to become the natural log of 3 over a minus b. Okay. Can't simplify this because that's inside of the argument, but I can say that's 1 natural log of this quotient. And that's as simple as it could get. Okay, let's try another one where we're going to write in expanded form. Let's say I had the log base 5 of AB over CD. Okay. Now, there is a nice shortcut when I've got that many pieces in my argument, but let's just work through that systematically. I would first of all say, hey, that's the log of a fraction, and a fraction is just a division problem. So I know when I'm dividing, I subtract exponents. So I can say this is equal to the log base 5 of the top minus the log base 5 of the bottom. Okay. So the one exponent for the quotient is the exponent for the top minus the exponent for the bottom. Now, each of these is a product. And the argument is a product. I know that I can break that up into a sum, because when I'm multiplying, I would add exponents. So this is going to become the log base 5 of A plus the log base 5 of B. I'm adding logs, so I'm adding exponents, and that gives me the one exponent for this product. Now I just need to be careful here. I'm going to subtract this. I'm going to simplify this, but I'm subtracting that whole thing. So make sure that goes in parentheses. Then I can use my product rule for logs to say this is the log base 5 of C plus the log base 5 of D. Okay. Now I'm going to go ahead and distribute that negative. So this becomes the log base 5 of A plus the log base 5 of B minus the log base 5 of C minus the log base 5 of D. And now you can see what the shortcut is. A and B were on the top. We got a positive copy of their logs. C and D were on the bottom. We were subtracting their logs, or we got a negative copy of their logs. So basically, when I see something like this, once I've recognized that, I can go straight to this. I've got 4 things connected by multiplication and division. Everything on top, I take its positive log. Everything on bottom, I take its negative log, or I subtract the log for that factor. Okay, so that's kind of a nice shortcut, and I am fine with you going right from here to here, but I wanted to show you why that works. Okay. All right. And so let's try an example of writing as a single log with coefficient 1. Let's say I had the natural log of 5 plus the natural log of x minus the natural log of a plus the natural log of b minus the natural log of c. Okay, a whole bunch of pieces. Okay. Now, again, there's going to be a nice shortcut. I'm going to work through this one just doing the addition and subtraction from left to right, one piece at a time, so that we can understand why the shortcut works. So, if I were to just do the addition and subtraction across from left to right, here I would say I'm adding logs. Adding logs means adding exponents. That corresponds to multiplication. So this will become the natural log of 5x minus the natural log of a plus the natural log of b minus the natural log of c. Okay. Now, looking at the next pair. Now I'm subtracting logs. Subtracting logs means subtracting exponents. I subtract exponents when I'm dividing, so this becomes the natural log of 5x over a plus the natural log of b minus the natural log of c. So now I can do this next pair. I'm adding logs. Adding logs means adding exponents. I add exponents when I'm multiplying. So this is going to become the natural log of 5x over a times b. Now, of course, when I'm multiplying by a fraction, I could write that as b over 1. So this becomes just, oops. Then I've still got the minus natural log of c. Don't want to drop that. So now I've got the natural log of 5xb over a minus the natural log of c. Okay. All right, so I've got one more step to do. Here, I'm subtracting logs. Subtracting logs occurs when I'm dividing. So I can combine these to say this is the natural log of this division problem. 5xb over a divided by c. But dividing by c is the same as multiplying by 1 over c. And so that's just going to put that c in the denominator. Okay. So let me just write my final answer up here. That's going to be the natural log of 5xb over a times c. Now notice, 5x and b ended up on top. 5x and b were the three terms where I had a positive copy of that log. A and c ended up on bottom. A and c were the two logs that I was subtracting. So similar shortcut to what we had before. If you're just adding and subtracting a whole bunch of logs, you're adding and subtracting a whole bunch of exponents, you can put it as one log or one exponent for an entire fraction. Everything where the log was positive is on top. Everything where the log was negative is going to be on bottom. Okay, excellent. So let me just give you two of these to practice on, one writing in expanded form and one writing as a single log with coefficient 1. Okay, so let's try this one right in expanded form, the log base 7 of 2x over y minus 1. Write that in expanded form. And then let's try the log base 2 of x plus y minus the log base 2 of 5 plus the log base 2 of z. Okay. Write this one as a single log with coefficient 1. Write this one in expanded form, and we'll start the next video going over those two problems.